A flux is, what exactly is a flux? Flux is a substance which is used to remove the gangue particles by forming slag. Therefore, flux plus gangue is equal to slag. You may ask, already we have removed the impurities by concentration. Then what is this? There may be some minute impurities which were not eliminated by the concentration process, so we require a flux. Therefore, here, what is this flux? Is it an acidic substance, a basic substance, a neutral substance, or either of these? Let me tell you, a flux is chosen depending upon the nature of the gangue. Reading my words. A flux is chosen depending upon the nature of the gangue, meaning it can be an acidic flux, it can be a basic flux, it can be a neutral flux. To give you a classical example of an acidic flux is SiO2. Example of a basic flux is calcium oxide. Example of a neutral flux is sodium sulfate. Therefore, the right option is a flux can be an acidic substance or a basic substance or a neutral substance. Option D is the right answer. The slag formed in the extraction of iron is, I said little while ago, slag is formed when flux combines with gangue. In the extraction of iron, we have charge. Charge is a mixture of ore, limestone and coke. Limestone acts as a flux, coke acts as a reducing agent. When limestone acts as a flux, CaO combines with silicon dioxide SiO2 to form what is known as CaSiO3, which is calcium silicate. The slag formed in the extraction of iron happens to be CaSiO3. Understanding that CaO is a flux, SiO2 is the gangue, CaSiO3 is the slag. The right answer is calcium silicate. Option B is the right answer. Next question. In aluminothermite process, aluminium acts as a very classical question. We are aware that in metallurgy, carbon is the most common and a suitable reducing agent for reduction of metal oxides into metal. But using carbon at high temperatures will result in the formation of carbides. Hence, there are a couple of other reducing agents such as carbon monoxide can be used, hydrogen can be used, manganese can be used, aluminium can also be used. If aluminium is used as a reducing agent, then the name of it is aluminothermite process. Repeating my word, aluminothermite process. Underlining, retracking my words. Aluminothermite process is that in which aluminium is used as a reducing agent. Hope you yourself can find what the answer is. In aluminothermite process, aluminium acts as a option A oxidizing agent, B flux, option C reducing agent, option D precipitating agent, option C reducing agent is the right option. When aluminium is used as a reducing agent, it is used in the reduction of oxides of chromium and manganese preferably. Hope you have understood this. Moving on to the next. Zone refining is a final stage in the extraction process. After concentration, removal of impurities, we have reduction, conversion of a metal oxide into a metal. Final stage is to get the metal in 100% pure stage, that is recovery of the metal in the purest form. We use one of the technique is zone refining. Therefore, I would like to tell, zone refining is the method of getting the metal in 100% pure state. Let's read the option to find. Reduction of a metal oxide, that should be reduction. Purification of the ore, not relevant to my question. Concentration of the ore, removal of impurities. Purification of the metal, this is suiting the right answer for the question zone refining. So, for underlining, zone refining is the method employed for purification of the metal. Therefore, option D is the right answer. Therefore, my dear students, I would like to enlighten you about, kindly go through the refining techniques that are there in the textbook. For example, you have distillation, you have vapor phase refining, you have Mons process. Similarly, you have zone refining. Looking for the principles of it. Definitely, you will watch up one question for the same. Refining of nickel is done by option A, Hall's process, option B, Mons process, option C, Bayer's process, option D, zone refining. Little while ago, we have capsulated one famous point telling that zone refining is a method of purification of the metal. Fine. Refining of nickel is done by, underlining statement, refining of nickel is done by Mons process. Then what are the other options that you have? Let me go through this. Hall's process is the method of getting aluminium from alumina. Mons process is the method of refining of nickel, which is the right answer, option B. Bayer's process is a method of concentration of alumina. Bayer's process is a method of concentration of aluminium ore. And the final one, zone refining, is used to get ultra pure metals. From this, again I would like to tell, read distillation process. Distillation is employed for all those metals which are volatile in nature. Distillation is employed for all those metals which are volatile in nature. Hope you got it and hope you have understood it. We'll begin with the next question. Which of the following ore has two different metal atoms? As I had specified in my earlier question, the more you know about the ores, their composition, it will be easy to answer this. Example, here you have hematite, magnetite, pyrolusite, copper pyrite. Hematite, Fe2O3, the most common ore of iron. Magnetite, magnetic ore of iron, Fe3O4. Pyrolusite, MnO2. Copper pyrites, we have discussed enough of it. It is a sulfur containing ore. Chalcopyrite, CuFeS2. If we happen to look into all these options, hematite, magnetite, pyrolusite and copper pyrite, It is copper pyrite which is having CuFeS2, understanding that copper is present, iron is present, matching to the contest. Which of the following has two different metal atom? Copper and iron both are present in copper pyrite, which is also read as chalcopyrite. Therefore, my right option and the correct option happens to be option D, copper pyrite. Again, if you could remember, this copper pyrite is concentrated by froth flotation process. Recap once again, froth flotation process, ore is wetted by oil, impurities are wetted by water. Hope you understood this. We'll move on to the next question.